Hello, everybody, and welcome to this Sparring Partners on AI-driven automation at AT&T. It's a pleasure for me to be here with Jen Yates. She is the Assistant Vice President of Inventive Science, Network and Service Automation at AT&T Labs. And I have to confess that that's the best title I've come across in a long while. Inventive science. I wish I had that title in my title, because we often forget that science and technology are not just arid, engineering, number crunching kind of efforts. There is a lot of creativity that goes in there to get good technology, good science, and especially a good use of technology. Said that. I want to, so this is the last, hopefully, maybe not, the last Sparring Partners on this topic. And this is part of a project and a report that just got published. And Jen's conversation will become part of the report eventually. And this is all about AI, GenAI, and how are they driving automation in networks that are becoming more and more open. And so there are sort of two, one way to think about it is that clearly we have new technology, which is AI driven, which is all good, but what is that for? How do we use it in practice in order to get our networks more efficient and basically through automation, at the same time that networks are becoming more open, more complex. And so how do we manage this whole process? So without further ado, I would like to introduce to you Jen. And as usual, I would like to ask Jen to introduce herself. So Jen, welcome to Sparring Partners. Oh, one other thing is the reason why I'm very happy to have Jen on the Sparring Partners is because she's really doing the work. So this is not, well, we never use slides on Sparring Partners, but we're going to talk from experience. So, what works, what doesn't, try to think about the reality of it rather than what could be. So I think it's going to be a very insightful and inspiring conversation. So Jen, welcome to Sparring Partners.
Thank you, Monica, for having me.
As I said, my pleasure, and I'm sure it's the pleasure of everybody that is in the audience and we'll see this later. Can you tell us, how did you end up at AT&T and what is it you do there?
Sure. It was actually accidental that I ended up in AT&T, to be honest. I was in Australia and got a job at AT&T and then had to make a decision on whether I was moving across the world or not. And clearly I moved across the world. I was coming for 2 years, but I've been here now 25. And that's all because it's so much fun to be part of this journey.
Yeah, absolutely. It is a lot of fun and there's a lot of change. And some people just like a little bit jaded, but really we shouldn't. I mean, it's really an exciting time. So what is it you do? Again, you have a beautiful title. So how inventive is your work?
Oh, our work is inventive. We have a lot of fun. Our role really is to innovate and to push the bounds of technology. My team has a focus on a pretty broad set of things, from analytics and network automation that push the bounds of technology in the RAN, and also location-based automation. So for example, 911. We also have, part of my team looks at across the network end-to-end, trying to understand the end-to-end performance, and even up to the application. What is the application experience on our network, and how should applications be built to actually work well on our network? We also have a big focus on energy efficiency and decom. So there's a broad range of technologies. The general focus is automation and analytics, but it always keeps us challenged and well engaged with the whole business.
Absolutely. And as you said, it's end to end because I guess like maybe even 10 years ago or even now, I mean, to some extent, you just focus on part of the network, you try to get that better, but that's not good enough anymore. You need to, you can't specialize, you need to be broad, right? So there's no excuse and no cover there.
Absolutely. Not just end to the network, up to the application as well. How those applications are built affects the network, and how the network is built affects the applications. It's a very complex and detailed ecosystem.
But I guess also more interesting. You're never gonna get bored, as you say. That's a good side
Never
of
boring.
things.
Never boring, that's for sure.
Okay, so I'm sure everybody wants to know more about it. So maybe we can get started to talk about, what is that? How do you approach AI and automation at AT&T?
Okay, we generally focus on where we're going to have the most impact, and where we can actually, frankly, manage the risk associated with deploying new technologies. So my team generally we've chosen to focus at the network edge for exactly those reasons. When we push the bounds of technology, deploy more and more AI and ML, invent and create it, we want to do it where we're going to have the most impact. And that is typically where there is the most complexity, where there is the largest scale. That's typically the network edge. And also, there's also less risk there, because if it goes wrong on one network element, it has less implications for the whole network, as opposed to if you're pushing the bounds of those technologies in the core. So we're really focusing on that journey, maximizing impact, and then driving it further into the network as well over time.
Yeah, so I have to, I'm not, I guess I'm not the best moderator here because I forget all the housekeeping stuff. So Jen, apologies. Let me
No problem.
Let's stop the flow here for 1 second and let me do this. I was so excited about introducing you that I forgot about it. So for all of you in the audience, you can ask questions, and well, you should ask questions, as many as you can, during our conversation. We do not have a Q&A at the end. And this is because we want to get your questions in to flow with our discussion. And so ask the questions whenever you want. I saw somebody's raising their hands. We cannot let you talk, but you can either send a question through the Q&A or through the chat. You can use the chat to comment. If you might have a comment, you want to share it with the audience, go ahead and do that in the chat. That's perfectly fine. So you can chat and do a Q&A, and we take the questions as we go along. So don't wait. The sooner you ask your questions, the more likely you have to have it answered. If you ask the question at the end, we won't be able to get to it. So anyway, so so we were talking about your approach at AT&T, and one thing you mentioned, as I was sort of thinking about what I was supposed to say, is the word risk. And clearly AI is going to, there is a huge AI and automation, it's a huge opportunity, but we need to be careful to make sure everything works as intended, or as much, how do we measure it? How do you make sure that well, there is a risk, but you don't run into, you avoid the risk, you just avoid the bad outcomes and
Absolutely.
benefits.
Absolutely. And honestly, how we've approached it inside AT&T is actually by building a safe automation program in collaboration with operations. We partnered with operations teams very early on, and frankly, really focused on learning from them. They've been dealing with the network their entire careers, and they know a heck of a lot that can really help us build safe automation. So through that collaboration, we focused on multiple facets of the automation to make sure that we built it all in such a way that it was as safe as we could make it for the network. That meant starting with the design of the automation, making sure that we designed it in such a way that if we encountered all sorts of crazy failure modes that do occur in the network, that we always left the network in the safest state or the right state, and that our automation could deal with all those failure modes without negatively impacting the network. We also made sure that we built essentially AI, watching our AI, making sure that if we saw something unusual or unexpected, that we took appropriate action so that that did not compound itself and make a big impact to the network. We also, of course, take very safe measures when we deploy our AI. And we make sure that we do it in such a way that we start small. We always test in a lab, then test in a small part of the field, and then gradually roll it out while closely monitoring it. And then we also obviously have to monitor it over time. Things can change in the network. For example, a new network software release that could break the AI. So we have to be completely on top of that, making sure that we know what new network releases are coming up, how they could impact our AI, and that we're always watching the performance of our AI over time. Operations have what I call the big red button. As far as I know, they've never have to use it, but if they needed to, it's there. And we also have our own inbuilt automation brakes, that if we saw the automation misbehaving, that would set off the brakes as well. As far as I know too, never actually executed in practice, because we have made sure that our automation is built in such a way that it is safe. And we have all the checks and balances along the way for each change that we make in the network. And we make a lot of changes to the network automatically.
Yeah, and I guess that's the whole point, right? That you want to keep improving, and the network changes. So there is like everything is changing, everything is more complex, and but also as we talked before, you need to look at it at end to end. So how is that changing the way you actually monitor? Because so operations might find out, oh, there is something weird here, we need to fix it. And I guess it's not a question of it's not a question of failure. It's like, this is not quite right. Right. I mean, it's not just you fail. It's not just taking the network down. It might be like, yeah, no, this is working, this is not working as well.
Yeah. So I think there's multiple different facets to that. There's making sure that the automation does what you're trying to do, like it's actually achieving the good you're trying to achieve out of that. So that involves ongoing monitoring that is very much dependent on the use case you're doing. So whether it's remediating issues in the network, then you need to make sure that you're not missing some of those issues, and that may result in you having to go back and optimize the automation again. So you always, depending on what it is, we have other automation, for example, that focus on mitigating congestion events. Well, we need to keep making sure that it effectively mitigates those congestion events. And if for some reason that would suddenly stop, we need to go back and understand why. So there's ongoing monitoring of the impact on the network, but we also have ongoing monitoring of the platform and the automation itself, be it the data quality. Are we suddenly seeing data that's corrupted? Because if we have bad data, that would impact our automation. And also, frankly, just looking at if the automation's behaving normally. So if we suddenly see an unusually high number of actions, that may be a cause for concern. We detect an anomaly on that. And depending on the use case, we may choose to actually apply what we call our automated brakes. Just stop, check everything looks right. Maybe it's valid and maybe it's a network, or maybe it's not, and maybe something has changed and we don't want that automation to just go too far. So there's monitoring at every aspect of it. Are we able to make the changes we want, or is there a problem in between? Maybe accessing the network elements. Every aspect of both the automation and the impact of our automation is monitored, both kind of locally and end to end.
Yeah, and I guess that, and this is something that came up in some of the other conversations we had on for the report, is that you might have you're trying to automate something, like you're trying to manage congestion, and that works perfectly well, but maybe that has some impact on, say, energy consumption, because if you try to reduce congestion, you're gonna probably increase energy consumption, and it might be at an acceptable level. So how do you deal with that kind of?
Yeah, obviously monitoring each of those aspects independently, and then looking at the causal relationships associated with that. If you suddenly did one thing and one automation, did it impact another? It actually goes a step further than that. And this is the concept of actually coordination, which is again part of our safe automation program. What we don't, with it, when we get more and more automation actually working in the same part of the network, or even across network elements, there could be a risk that one automation could actually negatively interfere with another automation. Just imagine if you had one automation that essentially said turn right and the other automation that said turn left, And we could be getting all sorts of confusion in the automation. So that coordination in the automation, both in terms of what it's telling the network to do, as well as its impact, requires careful thought, both in advance of deploying that automation, thinking about, well, how would they interact? How do they perform together? And then also, obviously, in monitoring it afterwards to make sure that it performs as we expected and there weren't any surprises along the way.
Yeah, absolutely. No, that's great. Now, let me ask you a further question. A further complication in this whole picture is that as you move to Open RAN, and AT&T is the most aggressive operator in the US moving towards Open RAN. So, you know, you're going to have an Open RAN a network that is more open. It has more moving parts. It's not just more vendors. It's more moving parts that you're going to be responsible for.
Yep, exactly.
Right. So how do you and so you're getting your network open at the same time you're getting it more automated, and you have to do that for it. But doesn't that create an additional complexity? And how do you do with that?
Without a doubt. I mean, the complexity is only increasing over time in these networks in all the ways that you mentioned. That is why we need the automation. We cannot scale these networks with the increased complexity without it. But to make sure we get it right, I'll go back to that key point. It's about collaboration across teams, making sure that all of the relevant partners that are the experts on the different parts of the network, whether it be the design of the network or the operation of the network, are at the table and they're communicating, because they all have incredible value to add in getting to that right position in terms of safe automation there. So we build on the automation over time, which is how we address the complexity, but we build it in partnership so that we make sure it works and actually achieves the goals that our partners, whether it's the RAN engineers in the market, the tier 2 operations teams, etc., we make sure that we address their needs and constantly listen to the feedback that we receive from them to improve the automation.
Yeah, and I think it's really important to listen to, because we're all learning, regardless wherever your position is in the value chain. I mean, from the analysts all the way to the people that go up on the towers and the vendors as well. Okay, so now let's talk a little bit about GenAI and LLMs, because so I should say traditionally, it's not really traditionally, but until recently, really it was AI and ML. And I still believe that that's really the core value, that's where the core value comes from. However, there is a lot of interest in GenAI LLMs. What's your view in terms of them helping you specifically?
Sure, absolutely. So I agree 100% with you. I mean, we've been using AI, machine learning, etc., in our network for quite a number of years. I'd say at least 10 years. But GenAI suddenly burst on the scene. That was something that we hadn't really explored in how it could use in our network until very recently. Now, these are things that are based on language. So it is different to a lot of the AI we've used in the past, which has been more focused on network data. So it's giving us a brand new opportunity to explore what we can do in terms of how we use machine learning on language. So we're exploring all sorts of applications, from being able to effectively mine tickets, whether they're customer tickets, network tickets, etc., to be able to understand better what's being done in the network by human beings, or the issues that people have seen in the network or in the applications, so that we can come up with better rules for how the network can react. Another area that we're actively working inside the company, and we've got users using it, is being able to ask documents and have someone, say, from an operations team, go and be able to explore what's in, say, vendor documents when rather than having to go and read them and find them all available on the internet or in internal repositories, find the right thing, they can very quickly and go and ask the question. One kind of really interesting application, in my opinion, that we've been working of late is how to essentially retrain expert engineers when they've been very used to dealing with one network technology and they suddenly need to shift and learn another network technology, say a completely different vendor. And so we've been exploring essentially how we can translate. If you're used to typing a certain command to address a particular type of issue on one vendor, well, how would you do that same equivalent thing on another vendor? And we've actually successfully been able to use GenAI to do that. So there's lots and lots of applications that we're exploring because it has opened up that new world, even just being able to go and ask questions of a data. One of the things we've found is that being able to put a GenAI interface on, say, some of our existing portals, it's avoided having to go and build some ad hoc reports. When someone just wants to ask a question, and historically we'd have to go and like pull it all together, massage the data, create a visualization for them. Now they've got the power to do that through our GenAI interfaces. So it actually also reduces the load on us as well when we create automation.
No, absolutely, because I guess there's a lot of information out there that, you know, it happens that only a few people know how to get to that information. And then now it becomes available. Also new hires, I guess, right?
Yep, new hires is a good one as well. Exactly.
How do you make sure that it's reliable information? Because that's, I mean, I guess, you know, what you have, it's not what it's on the internet. It's a sub, you know.
It's something. Well, yeah, so we are absolutely using techniques so that we can augment the stuff from the internet, essentially GPT. We have our own version internally, so it's all firewalled off to protect our proprietary data and even the questions that we're asking. But we augment that with a lot of data from the network or from documents associated with the network, our own methods and procedures, etc. They're all incorporated there. How do we make sure it's answering the right questions? The same way we do everything. Through very, very tight collaboration with our partners, try it out with them, learn, see what kind of questions they're asking, see what kind of responses the GenAI is giving back, get the feedback from our clients, our partners over in the operations team, and then keep reiterating. You know, yes, we've learned along the way that there can be wrong answers that come back. It's all about that partnership again and making sure we just keep pushing through and get until we get it right associated with that technology.
Absolutely. So this is a model you use is not one of the public models. Is that proprietary, open source? You bought it, developed? What's the deal?
So we're using GPT-4. We've incorporated that, put it inside AT&T so that it's within our firewall, but we are absolutely using the external LLMs. We don't have the resources to try to do something as well as they've done. But then, as I said, we augment it using documents as well and keep it current with what we've got going on in the network by integrating in with our data as well and our documents.
So it's like what some people now call the small language models, basically, right? So that you don't it's not a huge thing, because if you do a search on ChatGPT on the wide network, it's computationally very expensive because the data is so large. But I guess you have it restricted to your data, so
we're using
a much smaller model in itself.
Well, we're using the GPT-4 models as well. And then we integrate our data as well in with the RAG to make sure that we can look at both.
Yeah, you just tracks too. Yeah. Now you mentioned, so this is quite interesting in terms of you know that just I'm sure that a lot of people are very happy they don't have to go flip through a lot of documents, which they were like 99% are completely irrelevant until you find the right one. But at the same time, when you try to optimize the network, it's not verbal data. Hopefully, it's all I mean, whatever measure you use, whatever KPIs or traffic and whatever. So that's not language data. So how are LLMs helping there, or are they?
Okay, so LLMs do help us explore what's in that data, and they can help us with understand tickets and even some of the configuration data. However, LLMs are not really helping us understand the characteristics of the network data itself. LLMs are large language models. Network data is not language, or not typically language. Right. So what we are actually doing, and is purely exploratory at this stage, we're trying to understand if we can use these powerful techniques that have been used to create these large language models and apply those same techniques to network data. we're calling this that we're building a network foundational model. And so that's essentially a model of the network data. You can actually still query it using a large language model, an LLM, a verbal way to essentially go and explore that. But we're trying to go a lot further than that. And what we're trying to see is if we can actually then use this network foundational model for really two purposes. One is just to enhance our existing AI. And what we've found so far is that certainly in some of the applications we've explored, we can do it faster and frankly more effectively. It's more accurate using our very, very early network foundation models compared with the techniques we've used in the past. So that's exciting. But then going a step further and being able to be generative as well. I think one of the big challenges we've always hit in the RAN is that there are thousands of parameters that a network engineer has to configure for one cell site. Now multiply that by a large number of cell sites. There's a lot of art to that configuration, science as well, but art as well. And those RAN engineers have tremendous experience, but there's a scale issue here as well. So what we're exploring is if we can go beyond our traditional AI to be able to generate essentially new parameter configurations based on what we call multimodal models. In other words, where we're looking across different types of data. For example, trying to predict what the impact of, if we change a parameter, what will that do to the network? What we call a what if. And then we can decide if that's a good thing or not, and then go and do it actually in the field as well. Again, this is exploratory at this stage, but we're very excited with what we're trying to achieve here. And so far, so good on that journey.
Yeah, and I think that that's really, as I say, it's exploratory, but not just for you, for the world, I guess, and you and operators and vendors and so on and so forth, because the question is how AI, ML, and Gen AI is just many different tools, and how you combine them, or how you pick and how you make sure you get the best out of them. Now we have questions. And I just waited a little bit because now they're more relevant. So we have Ken, who has been a guest and frequent participants, asking about governance issues. The question is, how do you manage governance issues between operational departments and business units, between automations? What are the line management implications or rules in force? And I guess that, there is a governance, but there is also there are also emerging regulatory issues in terms of but so what's going on there?
In terms of governance,
that's a really important aspect.
It's a good question. It's a very good question. Thank you, Ken. So in terms of governance, I'm going to actually expand it a little bit to technology as well. Okay. So what we do is coming down to partnership plus a technology component here. So we have set up a governance where we have official approval processes for any new automation. Before we go out of what we call first field application, or FFA, we have to have tier 3, that's our operations team approval, that any automation is safe, essentially. They review what the automation does. We've got questions in there about how we have our checks and balances. For example, do we do pre-post checks whenever we make a change? And do we automatically roll back if those fails? Some of the automations need to have that, some don't. It doesn't work with them. But we have all of these questions associated with this. And before we're allowed to go out to FFA, we have basically outside of FFA, we have this approval process that involves them. It involves teams building the automation, and it also involves our RAM partners to review the automation in place and make sure that it is safe to go out. We obviously also review the results from the field, the first field application, FFA, as part of that procedure as well. But then there's also these checks and balances to make sure it's safe. But we also have automation and essentially technology that's in our platform as well that allows us to actually do a coordination between applications. You mentioned earlier about what if one application tries to turn left, one tries to turn right. Well, it's not technically turning directions, but it may be changing a similar or the same parameter. And then we can essentially express rules associated with how should this be handled if two of them are competing to do the same thing, which one gets priorities, etc. So this is configurable via policies, but it's essentially doing a pairwise at this stage, coordination between the two.
Absolutely. So that, I guess that's sort of a new level of control. I mean, you obviously had some kind of governance before too, but now it becomes much more important because it's out of your direct control. So
correct.
You need to okay. Now we have two or three more questions. There is the other one, which is from Fred. Is the question is, does your automation look at both cellular and broadband, for instance, Wi-Fi handoffs? And if you're talking about the report, I'm talking about generally. It's not specific to just a specific interface, but I think that it's more interesting to ask this question to Jen, because you guys are doing, obviously a lot of the traffic is Wi-Fi, but you don't have the same. So automation means different, something different when if you think of broadband or Wi-Fi.
Okay, sorry, there's just a question to clarify on the previous one, FFA, that just popped up from Ken. FFA is what we refer to, it's first field application. So think about it when we have a new automation or frankly a new software release in the network. This is standard practice across the whole network for pretty much anything that's deployed in the network. First of all, you obviously test it in a lab environment. And then what we actually do for the automation side, before we even go live in the field, we run it in what we call a safe mode. Essentially. And so what we're doing there is we're running the automation, but when we're talking closed loop automation here, which is most of what I've been referring to date, where we need to do this coordination, we don't actually take the actions. So we run all of the analytics live in the network. We can let it sit there and soak for quite a while. We can see what the actions would have been, but we don't actually take them. And so we can review them. Then the next step is this FFA or first field application, where we try it in a very small part of the network, see how it performs there, and then gradually expand it out into the network. So think of it multiple stage, lab, safe mode, or actually we also refer to it as dry run mode, then first field applications, then slowly scale it out as we go across the network. The network here is very diverse, very complex. So even once we've gone across all of those, we may still encounter a situation in another part of the network where we haven't ever seen before, because maybe it's a different configuration or something. So we then watch the automation as it goes every step as we roll it out. So it's a very careful, very deliberate process of expanding it to make sure that we deal with issues as they arrive. And we do see them as we roll them out.
Yeah, and I think,
scenario.
Yeah, and I think it's very important to acknowledge the fact that, which seems obvious. I mean, there are failures, right? I mean, but oftentimes people don't sort of they kind of gloss over that. And actually, that is, in a way, that's the most interesting part of the work, is to understand how can you push it to a point of failure without failing. It's not a point of failure, but you want to push automation farther out, but the more you push farther out, at some point you fall off the cliff. So you don't want to fall off the cliff, but inevitably at some point. So that actually is the most interesting part in a way. Okay, I said it, not you. But okay, so back to our question about the automation on just cellular, broadband, or Wi-Fi. What is your view?
Yeah, so we certainly have a lot of focus on how cellular and Wi-Fi can interact. None of the automation I'm directly involved with at this stage, or that I'm aware of, is actually focused across those two. That is largely happened on the device. And certainly we work with some of the device vendors to make sure that happens smoothly. And we do focus on making sure that and testing it, making sure they're smooth handover. But none of the focus that we have had is being specifically on that. Although there's obvious applications associated with that. And even just frankly, we have focused on what the content provider does or our internal policies associated with, say, end-to-end performance does impact user behavior and how they may fail over to Wi-Fi. But we haven't focused on the automation side of that because we just haven't at this stage, at least in my experience, seen the need for that. We do have automation, however, that works across domains. So we have automation where we may be monitoring the edge of a network, but the changes we make are in the core of the network. So certainly we've gone cross-domain, but not specifically, in my experience, at least on the Wi-Fi versus cellular.
Yeah. So it's a meta automation, and I guess that when it gets to orchestration and all that involved. Sorry. Another question from Aaron is, I'm reading the question. I am thrilled about what Jennifer described as how GenAI helped AT&T network operations. Could you talk about the challenge at AT&T in converting those domain knowledge to qualified data to be used and how to deal with it?
Okay, might start need to get some of my experts here on my team because they've been living and breathing this. But basically, yes, we've had to bring in additional data, as I said, and we're talking here. I don't know if he's necessarily talking LLMs or NFM. So I'll start with both. Okay, so basically what we're doing is, say, in the LLM space, where we're bringing in some of our own documents, it may be methods and procedures, it may be the vendor documents. So what we're doing there is we are bringing those documents in, we're essentially ingesting them, parsing them up, etc. And we're generally typically using existing technologies to do that. We try and use as much as we can off the web, publicly available stuff. So things like LangChain, we're using LangChain to help us essentially process those documents. Then we integrate that in with our GPT-4 using RAG. So that allows us to essentially bring in our own proprietary stuff or documents from vendors, etc. Bring it in and integrate it with the public models that we've got for the GPT, of course, ingested inside of AT&T, combine those two and allow us to actually ask questions on it. So that is that LangChain RAG technology, if you're familiar with those, that are key to actually achieving those. And of course, to get that, another technology that's key to us is essentially taking those documents, and if you're familiar with it, actually putting it into a vector database that's part of that as well. Now, in terms of some of the, if I take this question now and interpret it in terms of the network data, and I did see this question somewhere as well.
Yes, actually, yeah, that's the other question.
What network data? I'll go to the next one on network data. I'll take it there. So at the moment, what we've been doing is starting with individual data sources. And so we've started with KPIs and configuration as the first two that we looked at. We're expanding that over time, looking at other data as well. But those two are very, very key, as well as topology as well. And so what we are doing is we are essentially using, as I said, the same technologies that have been used in LLMs, but we're also exploring with different things. So transformer neural networks, GAN, diffusion models, etc. We're exploring all of these to see what works best. But we're basically just bringing that data in individually into individual models. And now we're combining them into what we call a multimodal model, so that we can actually look at how these two interact, so that we can get to answering those questions like, if I make this configuration change, what do I predict it? What will it do to my network KPIs?
Absolutely. Now, let me ask you this. Obviously, as an operator, you have huge, huge, huge amounts of data, and you can go into any detail. And so at some point, you need to know, and this is something that we discussed in some of the interviews, you need to find not only good data, but also relevant data, because you can have as much, just having more data doesn't make it any better. Sometimes it's worse because it's basically contributing to noise, right? So if you look, for instance, at the time distribution or the time granularity, you can be very granular. You can just get the data at the millisecond level, but it's not relevant to do to be at the millisecond level. because you won't see anything. But on the other hand, if you look at the data on the hourly basis, you might lose some of the data you need. So how do you, and for different purposes, you might need different types of granularity. Now, how do you deal with that?
How do we deal with that? Okay, so again, I'm going to go back to those things so key to me, which is partnerships. It's humans, it's expertise. So again, it's a mixture of expertise and technology. Okay, so by working well and collaborating across teams, we have a lot of expertise that kind of drives the knowledge of what is an appropriate timescale. So it does depend on the problem that you're trying to look at. Plus, there's always experimentation as well. Sometimes you just have to try it out and see what works well. So a combination of those two, exploration, and certainly being able to have the data that is stored in a way where we can look across those multiple time frames is key. So we will quite often pre-compute data on multiple timescales, so that we can explore it or we can use it across different applications for these. But again, I 100% agree, it depends on the application. And if you're looking for changes, that are on a very short time scale, obviously looking at long time scale data is not going to help necessarily so much. If you're looking at longer trends, you need those longer time frame data.
Yeah, absolutely. Now, I wanted to ask about a special use case that is, attracting a lot of attention. It's kind of the low-hanging fruit, which is energy efficiency. Because it just, whoever I talk to, they just mention that as the sort of a good use case that there's a lot of attention, and it's kind of more tactical. You can tackle it more easily than others.
Yep. And it's good for the environment too.
Yes.
It's got the side effects of social side. Absolutely.
So how's that working out?
How's that working out? Great for us. So we've actually been focused on energy efficiency, particularly in the RAN, for many, many, many years. So we initially, back a significant number of years ago, started with technologies like cell site sleeping. So what that does is essentially, under low network loads, it will put some of the capacity to sleep, and then if the load increases, it will automatically wake it up. We started with a straight consistent configuration across the whole network, and we used automation to make sure that we deployed it, and then made sure it stayed in the network, and that people weren't undoing that configuration as well. So we'd constantly go back and reapply it. But then we went to the next stage, probably 4 years ago, I guess, maybe a bit more, to actually say, well, how can we leverage AI to help us get more sleeping out of the network without impacting customer experience? And that is a key challenge with cell site sleeping, or any sleeping, is how do you make sure that you save as much energy as you can, but the last thing you want to do is negatively impact customer experience. So it's a real balance there. So what we did was we actually introduced machine learning there, so that we could actually select the parameters for each different cell site, in fact, each different face on each different cell size individually to optimize that. And then we used our closed loop automation to go out and deploy that. And of course, we have to re-optimize that on a regular basis to make sure it's appropriate. And what we found is we got about 30% more sleeping by taking that approach compared with the static approach. And now we're actually exploring using our network foundation model to see if we can do better. So far, so good. It's actually looking very promising that we can do even better in getting that balance of those trade-offs correct. But it's not just, everyone's talking about cell site sleeping. And without a doubt, it is a very good use case to deploy in the network, and has very, very high benefits and essentially good opportunity for saving energy. But we're also using machine learning well beyond that. Think of anomaly detection. It can be either temporal or spatial. And the spatial I actually find particularly interesting. I think temporal has been around a long time, but we're using machine learning to identify sites that are using unusually high amount of energy for their configuration and for their type of environment. Is it a hot climate? Is it a cold climate, essentially, in that particular region, or season as well? And so what we've found is that we ingest a lot of data about it. What's the configuration of the cell sites? What's the HVAC? That makes a huge difference because they're very power hungry. How many carriers, et cetera, associated with this cell site? What's the location of the cell site? Is it, in the middle of the country up north where it may be cold in winter, or down south where it's extremely hot? That makes a big difference. And then the machine learning essentially learns what is typical, what's normal across similar, and the machine learning decides what's similar cell sites, and then we'll pick out an anomaly. And so we've found issues that way with hardware. We've also found issues where, our power may be used by other people as well. And that's why we've got an unusual energy consumption in a given region. And then we have teams that we feed that onto who go out and actually investigate it and rectify the issues that are found. So it's not just the traditional cell site sleeping that everyone is talking about. We go further as well in terms of identifying where issues lie.
That's really interesting because it's kind of a broader view of optimization and energy savings. That it's not, I guess what you're saying is it's not just the immediate. It's to try to see the sort of big picture, if you wish, that what is good. And if something works there, maybe could it work here as well? Or is it just, it could be something that actually just doesn't work properly, right? And you just don't know that it's been like that, forever.
Absolutely.
But one thing that people are sometimes asking at this point is that AI clearly has a lot of computational demands, and that's a cost. And then it's a cost, but also it's an energy consumption. So the more AI you have, the higher your energy consumption goes at that level. However, you have an advantage in terms of energy reduction. So could you make the argument that in order to get this automated power savings, you actually end up using more energy to make it efficient than the efficiency itself?
I think it really depends on your use case, doesn't it? I mean, if the network's loud enough, I guess in theory you could. However, certainly it really does depend on the models that you're using. I have certainly seen models out there that are going to be a lot more power hungry and frankly make a lot more changes to the network and also actually have more risk to the network to achieve energy than other solutions. The solutions that we're using tend to be fairly efficient because we're not making we're essentially using the cell sites to actually decide when to wake up and when to sleep. They make those decisions locally with the approach that we're taking. It's much safer than having an external control, because what if you can't externally control and wake up? That's not an approach we're taking. But it also has the benefit that we are sending parameters over to them only on a as needed basis. We're not having to do this all day, every day. So we're pre-training our models, selecting the parameters, pushing those to the network, and then the network makes that decision locally on when to go to sleep and wake up. So that has advantages both in terms of safe automation, making sure that the network is essentially in control. And so we don't have the risk of automation causing problems from the network point of view, and then the customer experience point of view. But it also has the benefit of lower training needs than, say, some of the other solutions that we have seen out there in the industry.
So
there's trade-offs you can make.
So, I mean, to think about it, like, if you look at, in this case, power savings, but it could be anything, power efficiency, but it could be anything. You basically can have a sort of general high-level model you train, and then you deploy it locally. So it's sort of the same model, but then you kind of customize based on whatever the cell is, where it is, and that would allow you to reduce your edge computational requirements. So you have a lot of, you can do a lot of the training in the cloud where and it's just you don't have to replicate it. So there is a lot of streamlining.
Yes, absolutely. And that's what we're doing in this particular case. We do the pre-training, it's offline, and then we push the parameters to the network. And that pre-training only needs to be done on a periodic basis. And then, yes, the specific parameters that are optimized per cell site based on that pre-training are pushed to the network, and then, you know, let it sit for a while. When you see a need to retrain, we retrain essentially, as opposed to that machine learning being integral in the day-to-day decision making on what to do in the network. Obviously, it depends on the application, but there are some significant trade-offs between how you build your solution and how efficient that solution is, and frankly, also how it impacts the network.
Yeah, absolutely. Now we have another question about from Ritika. I probably don't pronounce it well, but anyway. Besides energy efficiency, do you use AI with the SDN controller functions?
Sorry, can you repeat that question? Sorry, I'm just trying to.
Yeah, so besides energy efficiency, do you use AI with the SDN controller functions? That's in the chat.
So my team is primarily focused on the network edge. We are in the process of virtualizing it. So yes, absolutely, the intent is to use AI there. There will there's less AI in the core. And everyone uses AI differently. So I want to be very careful that saying, I'll say it this way, there's less machine learning in the core. That doesn't mean we're not using it. Things like, for example, learning the best way to handle certain types of tickets. We're using machine learning for those kind of applications. So yes, it's being used from an SDN point of view as well. But most of our closed loop applications are more at the network edge for the reasons I said. And we're in the process of virtualizing it then. So yes, we would use it with the SDN, the virtualized controller there as well. Now, if the question is actually referring to, do I use the AI with the closed loop? Absolutely. So when I talked about the energy savings, those parameters are all pushed in a fully automated fashion to the network. There is no human being in the loop in that. We went through a stage where human beings were absolutely vetting our parameters, but we're beyond that stage. And so those machine learned parameters are certainly pushed to the network in a fully closed loop. And then those are one of those situations where we monitor when we push those parameters to the network, we monitor it. We look at if it's had any negative impact. And if it has, we'll roll it back and then we'll try again later. Because chances are the negative impact wasn't actually due to our automation. In fact, very rarely is it due to the automation. It may, but there's a lot going on in that network, and it may well be due to some completely and utterly unrelated issue. And that's why we just keep automatically retrying those until we say, oh, okay, chances are it was something else. So that's essentially how we handle it. Do we have other machine learning in there? We have certainly other applications as well. We use machine learning, for example, to quantify customer impact. And so in a RAN environment, it's actually very hard to determine what the customer impact is if you have a network issue, because we've got natural resiliency in that RAN, which is great from a customer point of view, because if a site has a problem, chances are the customers will just move to a neighboring site, which is fantastic from a reliability point of view, but a little more complicated from an analytics point of view. And so we've used machine learning. It's actually AT&T patented technology as well to quantify the customer impact of those issues. And then we actually prioritize all of our actions based on that, whether it be opening a ticket with the RAN team, whether it's causing a dispatch, etc., out to repair issue. Obviously, we want to prioritize the issues that are of greater impact to the customer as opposed to those that may be, for example, a greater impact to the network. We want to have a customer-focused, we do have a customer-focused approach in how we manage our operations teams and our operations actions.
Absolutely. Now, let me change the topic a little bit, which is the cultural change that goes with this. You mentioned many times you need to listen, you need to work with the different teams, but at the same time, you're asking them to behave differently, to do things differently, to basically give up control in a way. So it's sort of culturally hard to do, because you basically allowing an automated process to take over what you used to do on a personal basis. And you understand that you cannot do it, but that's a hard job. So how is this changing your internal relationships and also the relationships with the vendors, because this is change. This is way beyond technology, and I would argue that it's just as hard as the technology change.
Absolutely.
But maybe
Yeah.
you disagree on that.
Yeah. So, okay, again, I'm going to go straight back to those partnerships. It's about trust. It's about being on a journey together. I think certainly if we were to come along and say, we've got this automation, we're putting it in the network, too bad, that's not going to go down so well. So it is all about trust and having that relationship with the relevant partners, whether it be an external vendor, whether it's an operations team and engineers, and having them be part of creating this from day one. And then what we talked about earlier, the listening to their feedback. I have learned so much from listening to our partners, like all day, every day am I learning from them. In terms of what are the needs? What do they actually need us to do? You know, if you're addressing their problems, that really helps to getting them on board, right? And what are the risks and how should we mitigate those risks? We've learned a lot from them, those. So what we've found is so long as it's a journey with the key partners, the ones that are going to be impacted by this technology, it goes much, much, much smoother than if you would say to come in blind. That doesn't work. So that's key. In terms of the vendors, one of the things we're doing at the moment is with the advent of ORAN, and in particular the SMO, that's part of the ORAN standard, the Service Management Orchestrator, and some of the standardized interfaces like the R1 interfaces, all of these different standardized technologies are allowing us to open up our platforms and hence our network to increasing number of vendors. It's relatively new. The standards are just really becoming reality right now. So it's an exciting point in time where we can actually now be in best of breed automation with the vendors. So we're excited about that. But again, I think it's going to be that we're going to have to do that same partnership to make sure that now with the vendor solutions, we build the trust with the internal partners to make sure that that goes smoothly as well.
Absolutely. And yeah, I agree that trust is going to be, and trust is something you build. It's not something you impose. As you said, you know, it's not an act of authority.
No.
Okay, so we're getting close to the end, and Ken has a good sort of question as we're getting there. So the question is, there are industry expectations for 6G to be native AI. Based on your learning, based on what you're learning, what would be on your wish list for technology and technology standardization?
Okay, that's a loaded question there. Certainly from the ORAN point of view, one of the things I think we need to do is focus on enhancing that standardization. We would like to be able to make sure that we can build applications as easily as possible with the standards. At the moment, the standards or the ORAN specs are really relatively low level in terms of what you can manage. And so I think there's a lot of opportunity for us to go further with those specifications to make it much easier and more rapid to actually deploy our applications. I think there's also opportunities to be able to more tightly integrate with the network. Today, a lot of what we do is based on 15-minute KPIs or KPIs we have to calculate ourselves from very low-level data to be able to get it much, much faster. And there's delays in getting that data to us from the network as well. So being able to actually introduce AI more real time without the delays that we have to deal with today, I think that would be a huge opportunity as well. And again, looking at how we can more visionary, I guess, get to more fundamental foundation models across the industry. All networks are different, and ours is certainly different to our competitors. So that you can't use a single foundation model across the entire industry. But I think starting to look at how the industry can part together on those would be key as well.
Absolutely, yeah. Because I guess, yeah, as I say, networks are different, but not all that different. So there is some commonality there that can be used. Now, a final question for you. Are we ever going to have a cell site that is entirely built by a model drone, a combination of models, drones, and robots.
So
And
if
is
I
that a
put on
good
my,
thing?
yeah, is that a good thing? If I put on my academic hat here, okay, this ain't gonna happen
Yeah.
overnight. But little baby steps
It's
have
not
happened.
it's not a commitment.
No, it's not a commitment. Little baby steps have happened. We are using drones to inspect cell towers. I think it is inevitable. Time frame, oh, it's out there. And to achieve it, we've obviously got a lot we've got to do as an industry. We've got to have pluggable cell sites, with, you know, so that we can actually, you know, easily plug things in without a human being having to deal with all the intricacies that we do today. I mean, if you read in the just even in the newspapers, there's robots that are now inspecting railways. Well, will we get to the same point where they inspect cell towers? Quite possibly. And be able to use these plug and play more cell towers as well. And certainly the AI, I think, is the easiest part of it. Where we are today, we have a lot of situations where we need to go out and visit physical equipment, whether it be in the home, whether it be, you know, for more wireline services, it could be in cell sites, and it could be in a central office as well. With the advent of maybe even autonomous cars, robots, I do think maybe one day it's possible, but we're not talking 10 years. It's a lot more than that. I think it would certainly help us scale. And one point to add is that climbing a cell tower is one of the most dangerous jobs in the United States. And so mitigating risk and you know, human safety, I think, is a key part of that. So I'd love to see that vision. Yeah, it would certainly help in terms of safety and efficiencies, especially as we continue to scale technologies up. But it's a long way out there. Call it a pipe dream that we'd like to see one day. Today, we're automating everything that we can have remotely as much as possible.
Okay, well, we're going to have a next Sparring Partners, but not anytime soon, but we will. Well, Jennifer, thank you so much. I think that I can talk on behalf of the audience. It was great to hear your really hands-on experience about what's going on. It's all very exciting. So thank you so much for being with us today.
Thank you very much for having me.
And thank you all in the audience for your questions. And the video will be available in a few days, and there will be a transcript as well. And the upcoming Sparring Partners is going to be on APIs, as I mentioned, now new topic. And we're going to talk about what's good and what's bad about them. And the guests are going to be Markus Kummerle at Deutsche Telekom and Kamara, and Daryl Schuler at Reckon Analytics, and me. You can't get rid of me. So anyway, thank you all so much, and to the next one. Bye-bye.